keeping an eye on imaging. Discussion and commentary based on articles from JACC, Cardiovascular Imaging.
Welcome. My name is Alok Finn. I'm from Emory University. I'm an assistant editor at JACC Imaging. We're here today with Juan Granada from Columbia University Medical Center. Welcome, Juan.
Thank you.
We're here to discuss today Juan's paper coming out in this issue of JACC Imaging entitled Correlation of Angiographic Late Loss with Neointimal Proliferation in Stents Evaluated by Optical Coherence Tomography and Histology in a Porcine Model of Restenosis. Let's start, Juan, by discussing first what was the purpose of this study and the major findings of this study.
Thank you for the invitation. As you know, angiographic late loss is the most common variable used in clinical trials that aim to identify and discriminate DS efficacy. Due to the resolution of angiography, one of the main questions that we had is how can we discriminate differences between DS, and especially if late loss can discriminate those differences. So we decided to design this study in a very simple way. We got 49 stents regardless of the drug platform, but we had drug-eluting and bare metal. And we implanted these stents in the regular porcine animal model with the only objective of achieving different levels of angiographic late loss. Then we did in vivo OCT to really see and analyze the amount of neointima in every single stent and compare those results with angiographic late loss and histology. Essentially, what we found is a very nice distribution of neointimal proliferation and angiographic late loss. Approximately 20% of the stents had neointimal thickness that were 0 or less, as you sometimes see in clinical trials. Approximately the same proportion on the 1 millimeter late loss, and then the rest in between. Yeah. The most important finding is OCT and histology correlated very nicely, which actually tells you that whatever we got in vivo, we were able to correlate ex vivo with histology. Then when we compare those findings with late loss, the simple conclusion was when angiographic late loss was less than 0.55 millimeter, the correlation was very poor with both OCT and histology. If you see the linear correlation curve above that range, you actually see the correlation starts getting better and better and better. If you see previous literature, actually in human clinical trials, it's been suggested also that clinical events and actually angiographic late loss becomes relevant when the angiographic late loss approaches the 0.5 mark. So I think it's a very nice experimental way to settle this discussion.
So I guess talking about clinical implications of your study, if most of the current drug-eluting stents in the market today have a late loss less than 0.5 millimeters, what does that say about the ability of clinical trials using late loss as an endpoint to discriminate among different types of drug-eluting stents in terms of performance, restenosis propensity?
It is an extremely important question. I think that one has to be fair because this is an experimental model and you have to be careful with the translation into the human clinical arena. But I think the paper is very powerful in saying when the late loss approaches around 0.5, 0.55, your true correlation with angiography and histology, histologically derived neointimal thickness starts to correlate. Below that threshold, I think it would be very difficult to correlate one-to-one in terms of the specific efficacy of any given technology. I think it would be very challenging to be able to say that this technology is superior than this because it has 0.1 less
Well, that brings out the question then, do we need to be using a different endpoint in our drug-eluting stent trials in order to discriminate between stent types?
So this is actually an excellent question. My point is, if you really want to know what your late loss is, I think angiographic late loss is simple, cost-effective, simple thing to do. But in the way that I see it and based on this data, if you really want to discriminate or actually show efficacy over a different technology, you're going to have a technology with a higher resolution power of discrimination, such as OCT.
Juan, congratulations once again on this very nice paper, and thank you very much for your time today.
Thank you for the invitation.